Okay, let's look at this next example. We're going to determine the equation of a transformed logarithmic function. So what we did is we took this skinny line and transformed it to this thicker line. And the equation of that skinny line is y equals log x base 4. Okay, and I tracked a point on that original graph to the newer graph so you can kind of see what happens to that point. This point A, which is right now 4, 1, becomes 1, 1. And there are several things that we could do to create this kind of transformation. Well, I should clarify, only one, because we have specified points. But if there weren't specified points, there's two types of transformations that we could do to go from the skinny graph to the thick graph. So what do you think happened going from A to A prime?
Horizontal stretch.
A horizontal stretch by a factor of 1 over 4. Okay, so if I were to write the equation of the transformed function, what would it be? How would you horizontally stretch something by a factor of 1, 4?
I thought the factor would be the skinny line to the large line?
The skinny to the large, yeah.
Oh, okay. 1 over 4. Well, then you'd make B4 the function. So
Where do I put the 4?
you would put it before the x, obviously.
Yeah. Before the x. Right, if I want to horizontally stretch it by a factor of 1/4, I put a 4 in front of x. You see that? So that will quarter all of the x values. Another thing you could do, this is just kind of a side note, is if you notice this point right here, if you just kind of ignore the a's that have been plotted, or if those weren't plotted at all, this point right here got moved up 1. So you could also do a vertical translation of 1 up. But because they give us two specific values, this is really the only one that counts. But this x plus 1, this could also work. Right, if you were to graph them both, they would be the exact same graph.